Hello everyone. In previous class we have studied about different types of numbers like natural numbers, whole numbers, integers, rational numbers. This all information you have collected about it in previous class. Now today we are going to study about the real numbers. Before doing we'll start with the real numbers. Let's revise about the all numbers. Okay. So now today our mathematics part 2 second lesson we are going to start, that is real numbers. Okay, now before that we are going to revise all numbers. Now we have studied about natural numbers. Now natural numbers means what? Natural numbers. Now counting numbers are called as natural numbers. Now it starts from what? Natural number, that is denoted this set of natural numbers. We will say, we learn about sets, so we will say set of natural number as n. Natural numbers denotes by n, 1, 2, 3 and so on. They are infinite in numbers. This all we have studied. Now next is about the whole number. Whole numbers. Now see, whole number will be denoted by the set W. Now in the series of a natural number, if 0 is included, then we will call that all numbers as whole numbers. Okay, in a series of natural number, if a 0 is included, we say they are the whole numbers. Now whole numbers are also infinite in numbers. Now next type of numbers is about integers. Now integers also you have studied. Integers. Integer is denoted by letter I. Now see, in the series of natural number, in the series of whole numbers, and opposite of it, if it is included, then the series of integer will get. And integer set is denoted by letter I. Okay, so 0 and infinite. Now opposite of this means -1, -2, -3. This all is a set of integers. Okay, now next you have studied about the rational numbers. Now rational number, next is now all these are not denoted by their previous letter. Here you say natural number, so it is denoted by n. Here whole numbers, so denoted by w. Here integers, so denoted by I. But here rational numbers, so it will denote by r. No, these rational numbers are denoted by the set q. Okay, so rational numbers are what? The numbers which are written in numerator and denominator form, they are called rational number, where q is not equal to 0. In p upon q form we write about the rational numbers. Now see, all these numbers are included in the series of the rational numbers. Okay, what? P upon q. P and q belongs to integer, where q is not equal to 0. Okay. Now here what? Rational numbers are written in the form of p upon q. P and q belongs to the integers, but q is not equal to 0. Integers also are rational numbers because their denominators are 1. They are also represented, can be represented as rational numbers. Now Next you have to study about what? Real numbers. Real numbers, and it is denoted by the set R. Now see, these all numbers are real numbers. Means he is the grandfather. Real number is the grandfather of this all. Means what you say? See, N is a subset of W, and W is a subset of integer, and integer is a subset of rational number, and rational number is subset of real numbers. Okay, means what? All subset, when we say when all the numbers will present in the set W, then we can say that N is a subset of W. When integer, W is a subset of I, when we will say when all elements of W will present in I, then we can say is W is a subset of I. So this all are subset of this, all it is included in the real numbers. Okay, now we have to study, next part we have to study about the order relation on numbers. Now order relation on numbers, see how it is. Next part, order relation. Next is order relation on rational numbers. Okay, order relation on rational numbers. Now this is, suppose P upon Q is one rational number, and R upon is another type of rational numbers. Okay, now we know the three conditions for it. What? Either P upon Q is equal to R upon S, or we have P upon Q is greater than R upon S, or we will have the condition P upon Q is less than R upon S. When like this three conditions we will have, what we can say about it? First, what we can say is P into S is equal to Q into R. See, P into S will be equal to Q into R. Means product of P and S will be equal to product of Q and R. Okay, this one. Now second, what we can say, that P into S is less than R into Q, we can say. Then next, what we can say, P upon Q is, P upon S is greater than R into Q, and P upon Q, no sorry, what you have to say, P into S is less than R into Q. Okay, now this conditions we get. So this same condition it is given in the test book. See, we have three conditions. What? P upon Q is equal to R upon S, and P upon Q is greater than R upon S, or P upon Q is less than R upon S. If these are the rational numbers, then we will have the three conditions. What? Product of P into S will be equal to product of Q into R. Same way, second way, what we'll have, P into S means the product of P and S is greater than the product of R and Q. Same way, we'll have third condition, product of P and S is less than the product of R and Q. These conditions we will have. Now next we have to study about the properties of rational numbers. Next is properties of rational numbers. Properties rational numbers. Now see, what are the properties of rational numbers? We have one first property. First property is what? Commutative property. Commutative property. Now in commutative property, we have of addition and multiplication. What does it tell? Commutative property of addition and other is multiplication. Okay. Now what does it tells? That if a plus b will be equal to b plus a. We have studied this. A plus b means suppose we add 2 plus 3. 2 plus 3 will be equal to how much? 5. And 3 plus 2 also will be equal to 5. This property is called as commutative property. Means see, 2 plus 3 will be equal to 3 plus 2. Means that is same. Now next is what? Multiplication property of commutative. What does it tell? A into b will be equal to b into a. Means we have taken this 2 into 3 will be equal to 3 into 2. Means that is the product is same only. Now say second property is what? Associative property. Associative property. Now in associative property of addition, what does it tell? We have three terms, a plus b plus c, which is equal to. And we have a plus b plus c. Now we will do it? A plus b plus 3. These are the three terms. If we keep a as it is and if we add b plus c, then what? Same we are going to get. Means see, we have 2 plus 3 plus 4. Okay. Now we have added 2 plus 3. 2 plus 3 is 5. 5 plus 4 is 9. Now here what we have kept? 2 we have kept as it is. 3 plus 4. Okay. Now 2 plus 3 plus 4 is 7 and 7 plus 2 is 9. So this is associative property of addition. Same we have for the multiplication. Multiplication what? A into B if it into C, which will be equal to A plus B into C. Okay. Means what? If we do it multiplication of this, A into 3 into 4 will be equal to 2 into 3 into 4. Means what? 3 to the 6. 6 into 4 is 24. Okay. Same way here 2 into 12 and 12 to the also 24. This is what? Associative property of addition and multiplication. What does it tell? A plus b plus 3. These three terms are we are having. If we will add a plus b and then their sum, if you will add c, the sum is 9. Now same way, if we kept a as it is, you added b plus c. B plus c, the sum is equal to 9. Means either a plus b plus a plus b plus c or a b plus c, the sum is equal. Same way, product of a into b into c, if we will do it, or a keep as it is and product of b into c, their both product will be same. This is associative property of addition and multiplication. Now next is what? Identity. Third one is what? Identity. Now identity of addition, what does it tell? Identity of addition is what? A plus 0 is equal to 0 plus a. A plus 0 is equal to 0 plus a, which will be equal to a. Means either a plus 0 add or 0 plus a you add. Your sum is a only. Same thing you have for multiplication. But multiplication what? A into 1 is equal to 1 into a, which is equal to a. Okay. 1 a into 1 is equal to 1 into a, which will be equal to a. Means what? A multiplied by 1 or 1 multiplied by a, the product is a only. Same. Now next is inverse. Fourth is what? Fourth property of rational number is what? inverse. Inverse of addition and multiplication. Inverse of addition, what does it tell? A plus minus A. Means A's inverse is minus A. So their sum is equal to 0. Now A's multiplication of inverse is what? A. A's inverse is 1 upon A. So its product will be equal to 1. A into 1 upon A is equal to 1, where A is not equal to 0. Okay. Now these are what? These are the properties of rational numbers. Commutative property, associative property, identity and inverse. Now these properties you have to use while doing operation on rational numbers. Okay. Now next, which we have to study, that is decimal form of an rational numbers. Is either terminating or non-terminating. We have to non-terminating recurring type, that we have to find out. Now how we will find out? See, next part is of this is decimal form of any rational number. Now decimal form of rational number. Form of rational number. Now that will be what? Either terminating or non-terminating, or non-terminating. Okay, terminating or non-terminating it will be. Now how to identify whether it is terminating or non-terminating? Now we'll take the example of the number 10. Okay, 10. Now 10 is divided by 1. 10 is divided by 1. Then the division is what? 10. If 10 is divided by 2, the quotient is 5. 10 is divided by 3. Now 10 is divided by 3 means how much we will get? 3.333 means it is recurring. Okay. Now 10 is divided by 4. If 10 is divided by 4 means what it is? We can reduce 5 and 2. And 2 2s are 4 and 2 5s are 10. Is it? Okay. 2 2s are 4, 2 and 2 5s are 10. So 5 we have to divide by 2. Means 2 2s are 4, 1 remain. Now here 0.25s are 10. Means it gets 2.5. Is it? Like this division we have to do it. See, orally I had done it. Here 2.5 I got. Now how I got 2.5? Here what 0 will take. Then 2 5s are 10. So here the remainder comes 0. Means here 2.5 we got. Now are we getting here answer remainder we are getting 0? No. See, this also you want to try, then you can try this. 3s are 3 3s are 9, 1 remain. 0.0 into 3 3s are 9, again 1, again 0. So like this it will come. It will never, it will end. So it is 333 dot dot I have written it is. So is it terminating? The division is getting terminate. Now see here. Here we got 10. Here further the division is there? No. Here also no. Means we can write 10.0. Here we can write 5.0. Here it is there. Here 2.5. Means further the division is possible? No. Means this is what? This is terminating. Okay. Non-terminating, recurring spelling. Recurring means what? Now here 3 is recurring. Means how we can write this? This we can write in this way also. Now here dot. What does the dot indicates? This digit is repeating. One digit is repeating. If two numbers are repeating, we have to write the bar. That I will show you in front. Okay. Now here if I have divided by 5, then the this is answer is division is 2. 5 ones and 5 twos are 10. Now if I have divided by 6. Now 6 if we divide, then 6 ones are 6. See this division. 6, 10. 6 ones are 6. Remain 4. So decimal point. So 0. 6 6 6 are 36. Okay. 6 6 are 36. 6 36. So again remain 4. 0. Again 6 6 6 are 36. Means its answer is coming what? 666. It is repeating. So we'll write dot dot here. Okay. Now next is what? Next we'll take 10 upon 7. Now 10 upon 7 means again see 10. 7 ones are 7. Okay. So here remain 3. 0. 7 fours are 28. Now here 2 remain. 7 2s are 14. 14 then here 6 remain. 7 0 here. Then 7 8s are 56. 7 8s are 56. Then remain 4. 56. Then remain 4. 4 then 0. Then 7 5s are 35. 35 means 5 remain. 5 then 0. Then 7 7s are 49. 1 remain. Now see here again we got. Means here what? 5 7. Again we will get here 7 ones are 7. Means these digits are repeating here. Okay. Again this will come what? 1. Again it will come 4. Like this it will repeat. Okay. So this is what answer here? 1.4 2857. This is also further division is there, not terminating. Now next is what? 10 divided by 8. 10 divided by 8 means what we can do it? See. Here see this type of example it is not given in textbook, but I am explaining you this. Okay. So 10, 8 ones are 8. So this will be what? 2. 8 twos are here point. 8 twos are 16. So remain how much? 4. And here 0 means 2s are and 5s are. So answer of this division is 1.25. Okay. Now again by 9 we also will see. 10 divided by 9. So 10 divided by 9 will be what? 1 point. How much? 9, 10. 9 ones are 9. Again point 1. Again this will come what? 1.111. This bit will come. Means what? Dot dot dot. Okay. And here no. Now what? 10 divided by 10. 10 divided by 10 means what? 10 divided by 10 will be equal to 1. Okay. So this all we have got the answers of this. Now what we have, why I have done in this all division? To identify whether this division is terminating or non-terminating. By observation, by just seeing the numbers from the denominator, we can say that whether it is a terminating or non-terminating. So how to identify? See, if whose denominator will be the prime factors of 2 and 5, that numbers will be terminating. Rest all will be non-terminating. See here. Now, which we see the denominators of the rational numbers are 2. Here it is there. See 2. so its division is terminating. Okay, now here also factor is C. Fourth factor is what? 2 into 2. So its this also division is terminated. Here C 5. 5 is also terminated. Here 8C. Here 2 it is there, but 2's other factor is what? 3. Means here division is not terminated. Either you have 2's other factor can be 2 or 5. Then it is terminating. So here 8C. 8's also the division is terminating, and rest all others divisions are not terminating. Okay, so this you have to remember while solving the examples. Now see, when we have to convert the decimal forms, decimal point, the numbers of recurring digits after decimal point in the given rational numbers are according to 10, 100 and 1000, like this it is. Okay, now suppose the only recurring digit after decimal point, hence the convert it multiplied by 10. See, means here after the decimal point, if you have the one digit, then this you will multiply by 10. If you have two digits, then you will multiply by 100. If you have three digits, then you have to multiply it by 1000 to remove the decimal point. Okay, now we have to learn third part, next part, that is to express the recurring decimal in P upon Q form. Okay, next part we will see to express the recurring decimal in P upon Q form. Now how to do it? Suppose one example we have considered, that is 0.555. Okay, we have to convert this into P upon Q form. So what we have to do it? Suppose, or you can say let, you can consider this in textbook it is given x, you can consider x. Okay, so x is equal to, or you can write x is equal to P upon Q is equal to 0.55. Okay, 0.55. This was recurring. This is 0.555, which is equal to 0.5. This is recurring. X is equal to 0.5. Now here one digit is recurring. So what we will do it? We will multiply it by 10. Okay, so multiply by 10. This equation 1 multiply by 10. If you multiply by 10, then what it will be? 10x is equal to 5.5. Okay, what we have got? Multiplying by 10. This if you multiply by 10, the digit decimal point will get shift to the right side. Okay, so it will get 5.5. Now 5.5. Now this is, we got 2. Now subtract 1 from 2. Subtract 1 from 2. Then what? 10x minus x is equal to 5.5 minus 0.5. So it will be equal to what? 9x is equal to 5.0. Okay, therefore x is equal to 5 upon 9. So what will be the P upon Q form? So P upon Q form of this So of this recurring of this will be what? Is equal to 5 upon 9. Okay, which will be equal to 5 upon 9. In this way you have to solve. Now one more example I will take, which digits are repeating in 3-digit numbers we will take. Okay. Now second example. See, this you have to write in your notebook. This example which I have given from textbook. No. Now second question. Second is what? Express the recurring decimal. Express the recurring decimal. What? Okay, this is recurring. Now see, here what? I will write first step. X is equal to 7.259, which will be equal to 7.259. Now these 3 digits are repeating, so I will write bar here. Here see, 259, 259. So here on this you have to write bar. Okay. Now this we will name it as 1. Now multiply this 1 by, multiply 1 by how much? Now we have 3 digit repeating, so we have to multiply by 1000. Okay, if it is multiplied 2 digits are repeating, then you will multiply by 100. Now you will multiply by 1000. Okay, so it will be what? 1000 x is equal to what? 7259.259. This will be 2. Now what? Subtract 2 from 1. No, 1 from 2. You have to subtract 1 from 2. So it will be 1000x minus x is equal to 7259.259 minus what? 7.259. Okay, so it will be how much? 999x is equal to 725. Now here 9 minus 7 is 2.00. Okay, so therefore x is equal to 7252 upon 99. So this is the P upon Q form of this. So how you will write? Therefore at last write 7.259 is equal to 7252 upon 999. Okay. Now this we'll see the practice set 2.1. Practice set 2.1. Now first question. First question is what? Is classify the decimal form of the given rational number. Classify the decimal form of the given rational number into terminating and non-terminating recurring type. Now see, by mere observation you can tell directly without doing any division. First one 5 is in the denominator, means it is a factor. What I say, 2 or 5 if it is there, then it is terminating. So what you will write? 13 upon 5 is terminating type because their denominator are prime factor of 5. Okay, 13 upon 5 is a terminating type because its factor is 5. You can say prime factor or factor is 5. Now second is 2 upon 11. It is, you say it is non-terminating. Okay. Third one 29 upon 16. Its factors are 2. So it is a terminating type. Is terminating type because its factor is 2. Because its factor is 2. Now next is fourth one. Fourth one is 17 upon 125. Same thing you have to write. Otherwise you will apply shortcut. You have to write this here. This one, it is a terminating type because its factor is 5. Now next is 11 upon 6. Now it is 2 and 3. 5 is not there. 2 or 5. So 2 is there but 5 is not. This 3 is the other factor. Either it is 2 or 5, then we can say. 2 or 3, then no. It is non-terminating. Okay. It is non-terminating. Followed, understood this now? Now second type C. Write the following rational numbers in decimal form. Okay, you have to write in decimal form. So let's see question number 2. Question number 2. Question number 1 is 127 upon 200. We have to convert it into decimal form. So how it will be? 200 divided by 127. 200 divided by 127. So first one it will be 0. 0 and next it will be how much? If you take 0 then 0. Then subtraction is 127. Then we can take here 0 means 1 2 means it will be 6 2 6 okay. So 0 we can take this. Then how? 2 3s are 6, 2 4s are, it will be big. So 600 minus this is 1000. Okay. 7 minus 6 1000. So what? 2 5s are. It is 2 5s are 10. So it will be 1000. So the remainder is 0 0. Okay. Therefore what you will write? 127 divided by 200 which is equal to 0.635. Like this you have to write. Okay. Now we will see the second example. Second example is what? Second example 25 upon 99. 25 upon 99 means what we have to do it? 99. Now see, 99 is divisible by 25. No. So what we have to take? 0 point. Means here it will be 0. So 250 and 0 means how much that will come? 250. 3s are 27, means it comes big, so it will be 2s are. So how much? 2s are. So it is coming 198. 2s are 198. See, 2 9s are 18, 1 carry 18 and 1 19. So it is 10 minus 8, 2. Now here 14 minus 9. 14 minus 9 is how much? 14 minus 9. 14 minus 9 is 2. Sorry, 5. 5 and this 0. So here it will be 0. Okay, 5. How much are 2s are? So now 520. 520 means how much it will be? 3, 4, 4, 36. Yes, 4s are we can take. 4s are or 5s are it will be okay. 5s are. See, 9 5s are 45, 5, 4, again 9 4s are 45, again 4 carry then 49. So here it is 5. Now 11 minus 9. 11 minus 9 is 11 minus 9 is 2 and this 0. Okay, therefore again what we got? The same 25. So it will be what? 25 upon 99, which is equal to 0.25. Okay, what it will be? 0.25. Again it will come 2525 only. Okay, here again see 250 we are getting 0. If you put here 250, then again it will be 2 jar. So here this is again 2, again 5. So how we write? Therefore 25 upon 99, which is equal to 0.25. This bar, it is recurring. Okay, which are repeating, what we call them? Recurring. This you have studied in your 8th standard. Now next example we will see 23 upon 7. Okay. Next example. Now this one more only I will take and others you have to solve then after. 3. Okay. Third one is 23. 23 upon 7. So 23 upon 7. 23. 23 is dividend and 7 is divisor. So 7 3s are 21. So remain 2. Then here not divisible. So 0. 7 2s are 14. So here 6. This will be 0. 8s are 56. 4. 0. Again 0. 7 5s are 35. Then remain 5. 0. 7 7s are 49. 7 7s are 49. 1 remain. Means it is what? 23 upon 7 is equal to 3.2857. Okay, now they have said up to how much? Rational number in decimal form. They did not say up to how much you have to solve. You can solve, but still here we will get what? 1 we got. What? For it is 1, 0. Again 7 1s are 7. 7 1s are 7. Then how much? 3. Then 7 4s are 28. 28 then 2. Means from here see. What? 1 4. Again it will get what? 2. 2 8 5 7 1 4. Then it will be repeating. Okay. So this is what? Here 1 4. Follow? These 3 examples I have taken from this question number 2. Now 2 examples you have to solve. Okay. And third type C. Write the following rational numbers in P upon Q form. Now earlier 2 examples I have taken. Now I will take the second one, because first type I have shown 3 it is there that I have shown, 2 it is there that I did not show. So that I will show. Now this. Now next is Question number 3. Question number 3, second example. What? 0.37. We have to write in decimal form, that is rational number in P upon Q form. Means x is equal to, let x is equal to 0.337 bar. Okay, which will be equal, this is given, so directly we will write here 0.37. Now what? Multiply. Next step is what? Multiply equation 1 by 100. Now here two digits are repeating, so we have to multiply by 100. If 1 is repeating, then by 10. If 2 is repeating, then 100. If 3 is repeating, then 1000. Okay, so it is 10x is equal to what? 37.37. Okay, so it will be what? Equation 2. Now what? Subtract 1 from 2. Okay, so this is 100x. 100x minus x is equal to 37.37 minus 0.37. So it is 99x is equal to 37.00. So therefore x is equal to 37 upon 99. So 0.377, which is equal to 37 upon 99. This is in rational form, that is in P upon Q form. Okay, now this all practice set you have to solve, and this complete you have to solve in your notebook. Now thank you for watching this video.